Question 5, we're trying to space numbers around a circle so that the sum of pairs of numbers and opposite pairs of numbers is the same. So let's start with part A. We only have 6 numbers here. So we can see that 2 plus 4 is 6. So we will need to have a 5 here to make a 6 for this pair of numbers. We now have a 3 and a 6 to put in. And we can try both of these options, and we'll see that only one of these options works. We have to put the 3 here and the 6 here. So now that we've got part A out of the way, let's move on to the rest of the problem. Let's think about this condition that we have a little bit more carefully. So we have A plus B equals C plus D. I've left it as 6 circles around the edge, but it doesn't really matter. We can have any number. Let's think about pairs of opposite points. So we can rearrange this equation to say A minus D equals C minus B. So that means that if we consider the difference of these two and the difference of these two, the absolute differences are going to be the same, which solves part B. But I'm going to make a slightly stronger statement, which is that actually A minus D equals minus B minus C. So if at every circle around the edge we consider the difference of this circle and the opposite circle, then when we move around one, that will be minus what it was before. To illustrate this point, I have brought back the diagram we had in part A, and I have written these yellow numbers, which represent the number in the circle next to the respective yellow number, minus the number in the opposite circle. And we can see that these have the same absolute value as we go around, but they alternate their sign. Moreover, the fact that these yellow numbers have the same absolute value and alternate in sign is actually equivalent to the condition that we had to begin with. The reason for this is that if we consider these equations that we wrote earlier, the reasoning applies backwards just as well as it applies forwards. So as long as A minus D is equal to minus B minus C, we will have satisfied the condition in the problem. So now that we've turned our condition into a condition about these yellow numbers, let's consider the implications of what we have. So coming back to our example where n equals 6 again, we have k as the difference here and minus k as the difference here. This is telling us that x minus y equals k, and y minus x equals minus k. Now, these are just 2 ways of saying the same thing. And so if we consider each yellow number as an instruction, then our instructions are basically just repeated again on the other side. But will this happen for any value of n? Well, let's think about it. We know that n has to be even, or else it wouldn't make any sense to have one number opposite another number. But what happens if n is divisible by 4? Well then, the number of times we go round here is n over 2. And so the number of times that the sign of this thing changes is going to be n over 2. If n is divisible by 4, then n over 2 is going to be even, and so the sign will change an even number of times. Well, if it changes an even number of times and it starts off at k, at plus k, then it will end up at plus k again. So that will mean that x minus y equals k and y minus x also equals k. But that means that k has to be 0, because we can add these two together and get 0 equals 2k. In this particular problem, k isn't allowed to be 0, because that would mean that opposite numbers are the same, and we have to have all the numbers being different. But fortunately, in every part of this problem, n is not divisible by 4. It's divisible by 2, but not divisible by 4. And that's good because it means that we can go from k to minus k. It's an odd number of steps. And so the instructions are just a repeat of what there was previously, and that's okay. For parts C and D of this problem, we're focusing on the case where n equals 222. And we want to work out which values of k are possible. Of course, eventually for part D, we will want to work out which number goes opposite 1 or which number can go opposite 1. But this is basically equivalent to working out what the possible values of k are. OK, so how are we going to do this? Well, for each pair of opposite circles, we have the k and minus k. And as we stated before, these are the same condition, and it just says that if this is x and this is y, then x minus y equals k. So the question is, for which values of k can we partition the numbers from 1 up to 222 into pairs where every pair differs by k? If we can do this, then we can certainly satisfy the condition of the yellow numbers, and we're good. But if we can't do this, then it will be impossible. Clearly, there will be some values of k which are not possible. Part C invites us to consider the case where 1 is opposite 41, or in other words, where k equals 40. So in this case, we know that 1 is paired with 41. 2 has to be paired with 42, because it has to be paired with something with a difference of 40, and there are no negative numbers allowed, so we have to go up from 2. And in fact, every number from 1 up to 40 is going to have to be paired with something that is 40 more than it. And so on until 40 is paired with 80. We've now paired up everything between 1 and 80, and so we move on to do the same thing again, starting from 81. 81 is going to have to be paired with 121, because although there are things smaller than 81, and 41 is involved here, which is 40 less than 81, that has already been used. It's already been paired up, so we have to pair it with something greater. Similarly, 82 is going to have to be paired with 122, because everything smaller than 82 has already been paired up. And this pattern continues until we get to 120, which has to be paired with 160. You may be able to see where this is going. We have now paired everything up between 81 and 160. You won't be surprised to hear that we have to do the same thing starting from 161. Everything before it has been paired up, so it gets paired to 201. 162 gets paired to 202, and so on until 200 gets paired up with, it would have to be paired up with 240, but that's beyond our limits, so we can't do it, and this is impossible. So this solves part C, certainly, but part D is the important part of this question. So what have we learned from this? Well, it doesn't matter what value of k we start with. We know that the first k things are going to be paired with something greater, because there isn't anything low enough for them to be paired with. And so we pair up the first 2k things first of all, then we pair up the next 2k things and the next 2k numbers, and so on. And then if we're left with less than 2k numbers to pair up at the end, we have a problem. Now we know that if we are going to pair the numbers from 1 to 222 up into pairs with the same difference, then we will have to pair the first 2k up, and then the next 2k, and so on, until we pair up the last 2k at the end. This means that it will only be possible to do this if 2k is a factor of 222. If you haven't seen this symbol before, it means that the thing on the left is a factor of the thing on the right. So this is both a necessary and a sufficient condition, which means that if this does hold, then we can pair the numbers up like this. But if it doesn't hold, then we are not able to do so. So we're looking for the values of k such that 2k is a factor of 222. Well, if 2k is a factor of 222, that is the same thing as saying that k is a factor of 111. So what are the factors of 111? The prime factors of 111 are 3 times 37. So the factors of 111 will be 1, 3, 37, and 111 itself. So if k is one of these numbers, then we can split the numbers from 1 to 222 into these groups of 2k. We can pair them up into pairs with the same difference, and we can do the problem. But if k isn't one of these numbers, then we won't be able to do it. So to finish part D, all we need to say is for each of these values of k, which number will be opposite 1. 1 can only be opposite a number that is greater than 1, so it must be opposite the number 1 plus k. And the numbers that 1 could be opposite are 2, 4, 38, or 112. And those are our answers.